How's it going, everybody? In this video, I wanted to go over a common thing that I've ran into with ASA in regards to just really basic lab setup. So basically all I've done is in this lab is I've got two ASAs and four routers, and the routers are basically they're there simply for the fact of being able to test out like all the iOS security features, as well as VPN between iOS and iOS, VPN for iOS to ASA. I got some ASAs to do some testing with. So just to kind of add some complexity, if you will, because normally you're not going to put a router at the internet edge. You're going to put a firewall ahead of that, in most cases. So what I decided to do was I got the routing up and running. So all these ASAs included are running OSPF. So we do a show IP route OSPF. You'll see here that I have full reachability in the network from a control plane perspective. What that means is I have the 10.2.4.0/24 network down here, and that shows up right here as an OSPF route. That's the connection between ASA2 and R4. However, if I tried to go and ping said IP address, which is router 4's IP, it does not come back. Now there's an actual reason for that. Now, one thing that I'm doing on the ASA, if I was to go and try to ping 10.1.3.10, which is R1 to R3, that does work. Now the reason why is because the R1 to R3 connection, these guys are in the same security zone. So if we come out here and do a show name if, you'll see that inside PC1 and inside PC2 are both security level 100. I have also enabled show run same security. I have enabled both interface and intra interface with how that would be set up. So basically the idea here is this will allow you to do things like your router on a stick on a firewall, or your hairpinning, if you will. The other thing I've also done is a show run policy map. I have inspected ICMP on both ASA1 and ASA2. So we do a show run policy map. I've enabled ICMP. Now here's the thing. That enables me to ping R1 to R3. Okay, pretty straightforward stuff. What that does not allow me to do is that does not allow me to ping R1 to R4. The reason why, and back on ASA2, we do a show name if again, you'll see that my outside interface is 12.0.0.0/24. This interface is the outside. The reason why it's not working is because I am trying to ping from R1 to R4, so it goes from a high security zone to a low security zone. But because of the fact that I am dropping traffic on ASA2 coming inbound on that interface, there's no traffic being originated from R4 out to R1. It's R1 to R4. But in order for this to work, the high security level to the low security level, that has to be the flow. From high to low is allowed by default. Same thing with same security zone. I can communicate between routers in my same security zone. So to fix this problem, and even the inspect ICMP only works in the same security zone. So what needs to be done is we need to explicitly permit, for ping, we need to permit ICMP out. For Traceroute, we have to allow UDP. So if I do that Traceroute, let's see here. I do it, on R1. I do the Traceroute, it is also going to fail. The reason why it's going to fail is because of the fact that it's UDP out, ICMP back in. So here's what we're going to have to do. On ASA1, we're going to go ahead and go to global config and type in access list, and I'm going to say ICMP and extended, and we're going to say permit ICMP any. So now granted, and just for those of you that are security nuts, you're doing this on the outside interface? It's a lab. It's okay. I would be much more granular in a production environment. So now I've created the ACL. What I need to do now is I need to go ahead and apply the ACL. The way you would do this is access group, just like you would in iOS, except for this time you specify ICMP, and then you place it in on the interface that you want it to apply to, which in this case here is outside. So you type in access group, call it the ACL that allows the traffic or denies the traffic, inbound on the outside interface. So there you have it. Now I need to replicate this one more time. So I need to go and do a show history. So I'm going to grab this line of configuration and I'm going to take it over to ASA2, go to global config, copy and paste. So now if I go back to R1 and I try to do that ping again, I'm sorry, wrong IP. The ping works. If I go over here to ASA1 and I do a show access list, you're going to see that I have a hit. Let's see. It doesn't actually show it here. Normally it should show you a hit on that. Let's try that one more time. Let's go beyond. Repeat is 100. So on ASA1 we should see some. Oh, you know what? Show access list. Here, there's some hits right here. That's because of the fact that the reason why you're only seeing the hits show up on ASA2 is because from ASA1 the traffic is being originated from the high security level down to the low security level. So therefore it's being allowed by default. So the ACL is not being tricked, or triggered I should say. What would end up happening now if I were to go to R4 and do a ping 10.1.10.10, what is the IP of R1? Show IP interface brief. Yeah, it's 10.1.1. And now that works. Now I go back over to ASA1, I hit the show access list, and now it's got a hit count of 1. So let's go back over here to R4 and do a repeat of, 20. My pings work, go back to ASA1. My hit count goes up to 2 now. So that takes care of that. Now let's go back to R1 and let's repeat the process, but let's do the traceroute this time. Okay, so I'm allowed to go through, and you'll notice that, whoop, did not want to do that. I did not, in this particular case, you notice how the ASA doesn't show up? Because it's transparent. You can make it show up, but that's a different video. So what's happening now is the inbound traceroute is being blocked inbound on ASA2 on the outside interface. So I need to go ahead and create an ACL that permits that as well. So on ASA1, I'm going to take this same line of config, I'm going to do a show run access list. I'm going to take this line of config right here, but what I'm going to do is I'm going to say permit UDP any, because it's actually UDP for traceroute with this setup here. So I'm going to do that. So I'm going to basically add a second line. So do show run access list. You'll see that there's 2 lines now, and because I've added the line to an existing ACL, it's just another sequence number. So I'm going to go ahead and grab this line of config right here. I'm going to do the same thing at ASA2. Now if I go back to R1 and I try to do this traceroute again, it's going to get through all day long. And if we go to ASA1 and let's go ASA2 and we do a show access list, you'll see that there is another hit count, but this was for UDP. So the same thing goes for R4. If I try to go traceroute to 10.1.1.10 numerically, I can get there all day long. And if I go to ASA1 and I do a show access list, show access list, you'll see that there are 3 hits on that ACL, that access list entry. So that's how you're able to permit traceroute, that's how you're able to permit ping, and that's going from the outside to the inside. Because in fact you have to explicitly permit it. Now, why is that important? Well, because I want to be able to verify just basic reachability. And the only way to do that is to allow the traffic to go through. By allowing it to go through, you have full access to wherever you need to get to. Now, granted, and there's a question that a lot of people have, and it's a very legit question. How do you know what needs to be allowed? Well, the answer to that question is very simple. If I was to come over here, and if you look here, if you go to the monitoring tab of the ASDM, you go to the logging tab, and now I enable logging on the ASA2 in this particular case, and I'm going to go view the log. So what's going to happen is you get this real-time viewer. So if I come over here to this guy, and let me go ahead and bring this guy down just a little bit so you guys can see it, and do that, then I try to go back to R1 and I try to do this trace again, you're actually going to see the incoming connection. So how do you know what it is? Well, here's the thing, guys. You actually have to look at the log. What's actually hitting the firewall? This is the firewall, right? This is the actual the data plane. And you see right here, you see UDP. Inbound UDP connection is built. Now here's the thing. If you don't know what's blocking, I have a very normally will come in here, and if customer calls me up and says, hey, there's a problem, I want to see what the ASA is seeing. So I can do that. Now I can come in here and I can type in UDP, and that's going to block only show me UDP traffic. If I want to see ICMP, it's going to do the same thing. If I want to go from R1, I want to ping, it's going to see it sees the inbound pings, right? Now it only shows up once because the fact that all I had to do is it checks the state table, and there's like, okay, there is an ACL that does that and allows me to go through. Now that's a real-time log viewer, and I've used this repeatedly. There is one other thing that I want to show you. It's called it's under the Tools tab here, and it's called Packet Tracer. Now what Packet Tracer does is it allows you to basically trace through the ASA how traffic is traversing the ASA. So you can pick the interface, you can pick the protocol, all that stuff. So here's what I'm going to do. This is ASA2, and I want to say from inside PC5, which I believe is the PC4. I'm going to go inside PC4. Actually, I don't even have that. I don't have that one set up yet. Or wait a minute. ASA2, show interface IP brief, show name if. Oh, I named it. Okay, it's improperly named, but that works. So that's fine. So I'll say from this interface, I want to do a UDP packet. The source IP address is going to be, in this particular case, it's going to be 10.2.4. 100, 200. .200 to, and the destination IP address is going to be 10.1.1.10. And I want to go ahead and I want to start this. So what it's going to do is it's going to go through all the 0, and the source port is going to be, destination port is 0. 1 and 1. So what it's going to basically do is it's going to throw this little syntax. It's packet tracer input inside PC5 UDP from the ASA port 1. So the IP address of the ASA on port 1 to the IP address of router 10, or I'm sorry, router 1 on port 1. I'm going to go ahead and send it. What it's going to do is it's actually going to go through all of the aspects of the firewall, and now the packet was dropped. That's because of the fact that I don't, let's see here, I need to go to router 4 and do a show IP interface brief. I'm .4. So I want to actually change the source. So I'm going to say .4 close. Oh, that's not what I wanted to do. Tools, packet tracer, and then start. Yes. So basically I'm going to be, so now it's going to go through the full thing. It's going to do, it's going to look at every lookup that has to be done on the ASA in order to allow traffic to go through. And if I've done my job correctly, I know it works, and you can tell that the packet is allowed. So what it does is it does a route lookup, first of all. It says, do I have a destination? It does. So it goes to there. It does a NAT lookup. There is no NATs enabled, so it's just, you know, the ASA is doing what it's doing. The IP options, nothing's there. QoS, nothing there. Another QoS, nothing there. Another NAT. Now this is inbound on the inside interface, and this is outbound on the outside interface, because you can NAT on both interfaces. IP options allow. And so basically what's happening is I'm going through every check on the ASA, and what it's basically doing is it's saying, okay, from router 4 to router 1, as long as it's UDP traffic, go ahead and allow it to go through. Now I can do the same thing with ICMP, and this source address is going to be 10.2.4.4 to 10.1.1.10. The type is going to be a echo, and I can go ahead and start it. That cannot be empty. Code 0, ID 0? Yeah, so send. So what it's going to do is it's going to run through this to see if it's actually going to allow the ping. Now if there's a problem along here, I can pull packet tracer up and say, okay, where in the process of ASA route lookup does the packet either get permitted or does it fail? In this case here, the packet is allowed. And that's because of the fact that I've done that. Now here's the difference between the two. Notice there's an inspect here. Notice there's an inspect ICMP right there in the global class map. There's also an inspect here. But this inspect is a little bit different. I don't know how different, but it is different. So basically what's happening as you go along is the traffic is completely pushed forward. So this is kind of cool when it gets into the details, because it allows you to actually see what the ASA is doing. It's great from a learning tool because it lets you see all the different types of traffic. Now to be brutally honest with you, ASA is a layer 2, 3, 4 filter. It's really, really good at doing that. So if you want to do anything beyond that, firepower and identity services engine is where that comes in for your application level stuff. So I'll be doing a bunch of videos on those. I just you know, show you guys how stuff goes in ASA and ASDM. But let me go ahead and from the CLI, let's go ahead and show you guys what that looks like. Let me go and pull my topology up here. So what I'm going to do is on ASA2, I'm going to do the same thing. I'm going to say packet tracer, say input from inside security, and I'm going to say that the it's going to be ICMP, and the IP address in this particular case is going to be 10.2.4.4, and the ICMP type code is going to be 0, and it's going to be, sorry, it's 80, and then the destination is going to be 10.1.1.10, and if you want the output to be in XML format so you can see it in ASDM, you can, or you can do detailed. I'm going to just hit the enter key, and what this is going to do is it's a CLI version of the same thing. So if I come in here and I go all the way down, I look at here at the top, it says route lookup. The traffic is allowed, which means it has an egress interface. It's allowed in the NAT statement, in the NAT session, and there is an ICMP inspect role. So it looks in there, it sees that ICMP is allowed. Now if ICMP was not allowed, it would actually come in here and say deny. So it would give you that output. And this is what's cool about, you can look at it from both ASDM and from the CLI and go through and go, okay, well, whereabouts is it being blocked? Is it a flow? Is it an ACL? Now, what I've got set up here is extremely elementary. Very, very basic stuff. I have a security CCNA, but I'm in the process of going back through and just going back through it again. It's been such a long time since I've done it. I'm getting reacquainted with ASA just so I can play with it and going from there. I hope this was informative, guys. I'll be putting out more content like this as we go along, and you'll see stuff for iOS, ASA, Identity Services Engine, Firepower. Let's see what else is there. The Web Security Appliance, so on and so forth. It's because of the fact that I haven't given up on service provider. I've just put it on hold because of the fact that I'm working much more heavily in the security side. So I figured, you know what? Why not just go headlong into it? And I've got 100% support from my employer. He's all about it. He's like, just dive in as far as you want. When I went to Cisco Live, I did a lot of security sessions. So you know what? The more and more I dig into this, the more and more cool I think it is. And we're going to go from there. Until next time, guys, thank you so much for stopping by. We will catch you later. If there's something you would like me to cover or you'd like to see something done, please let me know in the comments below. Until next time, guys, you guys are awesome. Thank you so much for stopping by, and we'll catch you guys in the next video. Take it easy, guys.